So again, this is a population growth or exponential growth problem, so we want to use that same formula. So the population is growing at a rate of 2%. So my end amount, okay, we have our end amount is 40 million. Our starting amount is 30 million. Our growth rate is 2%, so I'm going to multiply by 102% for every growth cycle, and that is every year. The growth cycle is years. Okay, so how long before the population grows to 40 million? I need to solve for y, so I'm going to divide by 30 first, so I can convert it to a log. Now we can log both sides and use the power rule. In fact, since the last example, I converted it to a log. This time I can do the same thing, but I'm going to just log both sides of the equation. So I'm going to get log of 3 over 4, and I get y log 1.02. Okay, so I brought the exponent to the front, and then I want to solve for that y, so I end up with log of 4 over 3 divided by log of 1.02. Again, that involves using our calculator. So we have log 4 divided by 3 divided by log 1.02, and that gives us 14.527. So I'm going to round that to 14.3 years. So 14.53 years. So that's part A. So the second part of the question is, what is the growth rate needed for the population to double in 10 years? So what I want to do is I want to start with 1, end with 2, so that's doubling. Now my growth rate is unknown, and I'm going to do this in 10 years. So we're solving now for the base, so that represents, this is not a log problem, this is an exponential problem. So I'm going to do the 10th root of both sides, and that will allow me to solve for x. So if I do 2, the 10th root of 2, I end up with 1.0717, so I'm going to round that to 1. So x is equal to 1.0717, so 0.072, and then that represents the rate that we need is going to be 7.2%, and that's an annual growth rate, so 7.2% per year. So these problems are to do with the geometric sequence and series. So the geometric sequence is our exponential growth sequence. So it's going to be Tn is equal to our starting amount, our growth rate, our common ratio, and it's going to be to the n minus 1. We have a minus 1 in there because of the fact that we start counting our sequence terms from 1 and not 0 like we do for functions. So this looks very similar to the exponential growth formula, except the growth cycles start at 0, whereas the n values start at 1, so we need to compensate for that. So to do this, we need to first of all identify our starting amount. The starting amount is A. Our growth rate is going to be the ratio of those two terms. So our growth factor is times by 1.5. Okay, and we want to find the 8th term. So calculating T8, we start with 8, our growth factor is 1.5, and then we're going to increase that 7 steps, or 8 minus 1 steps. So putting this into my calculator, we end up with 8 times 1.5 to the power 7, and that gives me 136.6875. I'm just going to leave it like that, actually. 138, 136.6875. Okay. Here we're given two terms of the geometric sequence, but we can use, when we need to find the common ratio r. Well, we can say that the common ratio r is going to be the number of times we use the ratio is going to show up between t to the power, the b term, or tb, divided by the a term. Okay, so that ratio, so in this case, I've gone from 3 to 10, or 7 steps, and those 7 steps should be reflected when I divide T10 with T3. So there's my 7 steps, and then 1536 divided by 12 gives me 128. Solving for r, I take the 7th root of that. Okay, so 7th root of 128 is going to be 2. And so the common ratio is 2. So what I've done is I've doubled from 3 to T3 to T10. So my sequence looks like this. There's my third term, dot, 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 dot. And then this is going to be my 10th term. So that's T10, T3, and I want T1. So I can just go backwards, divide by 2, divide by 2, and I get my answer. T1 is equal to 3. Okay, we could also put it into the formula. And since we know we're looking for T1, and that's going to be equal to, oops, we can just say that we have a T3, so we can say that T3 is 12. This is T1 times the common ratio of 2, and T1 to 3 is going to be 3 minus 1 times. So 12 is equal to 2 to the power 2, and then we can solve for T1 that way as well using the formula.